Okay. Next is matrices. Okay. Matrices are created by matrix function. Okay. And of course, these are vectors, except vector is just one dimensional, then it will have two dimensions or more than two dimensions. The number of rows, um, the dimension attribute is an integer vector of length 2, so number of rows and number of columns. So that will be the matrix. And there are some data analytic procedures that expect a matrix data. So we often convert a data frame into a matrix, okay, and that's done with as.matrix. Okay, as.matrix and give it name of the data frame, then that will convert the data frame into a matrix, and then you can send it for you can send it as an argument to a function which will perform some kind of analysis. Okay, so suppose we say M, assign to M the matrix, right? And we have two parameters or two properties, n row and n col. Okay, so now of course I need to first insert the chunk, and then okay, then if I run that, then it sets up a matrix, a blank matrix with two rows and three columns. So we can supply values to the matrix function. Okay, so 1:6, so that's a series of numbers 1 through 6. Then n row equal to 2 and n col equal to 3. And then so those six numbers are then populated into the matrix. Okay. Now if you have a series of numbers, okay, so M has a series of numbers, right? 1 to 10. Now if you apply, so this is just a series of numbers 1 through 10, right? Then if you say dim of M needs to be, okay, you give that as a vector 2, 5. So now it's going to force that dimension to M. Okay. So M is right now a list of numbers 1 through 10, and this dim function is going to enforce a dimension to it, and that would make it into a matrix. Now matrices can be created directly from vectors by adding a dimension attribute. So that's what this is. So here is a vector, and then we put the dimension into it, then that vector is converted into a matrix. So that should go here. Okay. Then matrices are entered column wise starting from upper left, so that would be this. Okay. Column binding and row binding, so C bind and R bind, if you have vectors that can be put together, combined into matrices. Okay, so let's say we have X is 1 to 3, y is 10 to 12. So x is 1, 2, 3, y is 10, 11, 12. Then if you say C bind x comma y, okay, so that will combine the two as two columns. Okay. Now the C bind and R bind are very useful when you run data analysis and you have lots of output coming from different analysis and you want to combine them all into one single table. Then C bind and R bind are very useful for that purpose. Okay. So these are inserted one column at a time, and if you did R bind x comma y, so that will be combined row wise. Okay. And we haven't looked at data frame yet, but let's say we create a data frame, okay, with data.frame, and then we're going to give a name for the column, okay, say V1 equal to 1 to 4 and V2 equal to T, T, F and T. So that's logical, right? So now we have a data frame with two columns. First column is integer 1 to 4 and second column is V2, and that's logical. Okay. Now we can convert this into a matrix by going as matrix df. Okay, so now that data frame gets converted into a matrix, okay, and the logical is, now remember it has to be the same type. So the atomic vectors combined together, so the matrix is an atomic matrix. Okay, so all the values are coerced into numbers.